Hi, I'm Brennan, and this is Lewis and Ian. And Lewis is going to talk to you guys a little bit about the backstory of our project.
Okay.
Yeah.
Okay. Toy cars have appealed to boys of all ages since the invention of the actual car. Group 6 set out to create a car that would appeal to boys between the ages of 5 and 10. Our toy is called the Speedster, and it will hopefully ignite the imaginations of future racers and engineers. Imagine you are sitting at the start line, waiting for the lights to turn green. The tension builds, you rev your engine, you grip the wheel. The light turns red, orange, green. You drop the clutch and race towards the quarter mile. You cross the line and deploy the parachute, and the car comes to a halt. You feel the adrenaline pumping through your veins. With our toy, we wanted to capture the emotions of drag racing, letting the imaginations of our target audience run wild as they take part in their very own race. The idea of our toy is to bring all the elements that make up the spectacle that is the quarter mile drag race to warm up the tires, rev the engine, you pull the toy backwards, winding up the inbuilt motor. Two competitors line up their cars, waiting eagerly for the call of on your marks, set, go. They release the cars and they race off the line. The internal mechanism starts to work, and as the car crosses the line, the parachute deploys, bringing it to a halt. Both competitors can then take their cars, repack the parachute, reset the mechanism, and they're ready to race again. Our toy offers fantasy, construction, and competitive play value. Because it is able to be reused over and over again, we believe our concept has great potential. I'll now hand over to Ian to talk about the design and construction aspects.
Okay, so this is
He needs the
basically
mic, the microphone,
Oh,
and it's off now. Okay, thank you.
is it on now? Okay. So this is all the parts that we basically modeled through CAD. Over here, the stuff in the color is basically what made the car run, and then also our parachute deployment system. This is just another view. We pulled it out. This is what we started with. This is a motor from a Lego car that we bought. This is what powers our car. And then we added on an axle of our own so that we would have something long enough for the back tires. And we also added on 2 teardrop type gears to help with the launching of the apparatus. Here we have kind of like it's basically like a stopping mechanism. It goes through this chute. Basically the teardrop gear will launch it up and over this little hump that you see there, allowing the spring with the parachute attached to it to fly free and release the parachute from the car. Again, here you can see the parachute is attached to the motor, and it will fly out the back door, the hole in the back door, once the green stop mechanism is pulled out of the way by the teardrop gears. And then here's a video. Yeah, it's up there. It's trying to work. Okay, here we go. No, there's no volume, don't worry about it. Okay, as you can see, the motor worked very well for our Lego car, so we moved forward with it. However, our model has a bit more friction, it's a bit larger, and it's a bit harder to get moving. So our motor wasn't quite powerful enough to actually work our car in the manner that we wanted it to. So if we were able to go back, we would probably go out and find a better motor if possible. That's all we have. Do we take questions or anything? All right.
Can you show it? Is it working now, or?
It's basically just that over again if you want to watch it.
So how does the parachute deploy?
Inside, we can go back. Okay, so there's a spring and a spring attached that this is attached to. and it's attached to a small, like, square type material. And you push the spring back so it's loaded behind the green part, and the green part falls down and holds it in. So then when the teardrop circles around, knocks the green part up and away, then the spring decompresses and shoots the parachute out the door.
Can you demonstrate how you wind it up or it deploys on the actual model?
Again, we took out the deployment system because the friction was too much to overcome, but you can just turn it back and then it rolls. I mean, it needs a little help. The friction is a little too much to overcome for the small Lego motor.
Did you compare this to other toys that are wind up toys like that are already on the market?
Yeah, we actually used the Lego toy that it came with and basically did a handful of tests on that. But I mean, it was modeled and made for the Lego toy that we tested it on. Not, this is much larger than the toy that we tested it on.
So I noticed that the front of your toy is very pointed.
Uh-huh.
What will happen upon impact?
The whole thing's pretty sturdy. It has gotten some bumps and bruises throughout the process. So, I mean, we don't really think that there's much of a problem in that aspect with the toy falling apart if it runs into something. That probably is a danger. And, I mean, if we are marketing it towards smaller children, we probably should round it off. All right, thank you.